Okay, welcome back. So let's take a look at these division ones. Now you've had a chance to give them a try. So using the division rule, if you're dividing two radicals, you can combine them under one gigantic radical. So it'll be the square root of 51 over 3, all under one root. And 51 divided by 3 gives you 17, so all this is root 17. Over here in F, same ideas with multiplication. We got coefficients, we got square roots as well. So let's divide the coefficients first. So I get 28 divided by 7, which is 4. And if I combine these square roots under 1, this is the square root of 44 over 11, which will simplify because 44 divided by 11 is 4, so I get 4 root 4. And hopefully you can recognize here that square root of 4 is 2, so I get 4 times 2, which is just 8. Okay, so you can deal with the coefficients and the square roots separately. Okay, and if you look at G on the surface, it doesn't look like there's a whole lot we can do with it. There's two different ways of going about trying to simplify this one. Because we have nothing in, not both numerator and denominator under square roots, we could, if we want to, write 7 as a square root. So we could say this is equal to square root of 98. And if you want to write 7 as a square root, well, 7 squared is 49, so 7 will be equal to the square root of 49. Then you could say, okay, this will be the square root of 98 over 49. 98 divided by 49 is 2, so all this will be equal to root 2. Okay, that'll be one way of approaching this one. The other thing that you could do instead is try and express root 98 in lowest terms. So if you look at root 98, just look at 98, the perfect square that can go into 98 is 49. So you can rewrite this guy here as the square root of 49 times 2. Oops, sorry, it's a 7 down there. And if you do that, you get the square root of 49 times the square root of 2 all over 7. And the square root of 49 happens to be 7. So you get 7 root 2 over 7. Those 7's cancel, and you're left with the exact same thing. You just get that with root 2. Whichever way you find easier works for me. Alright, let's look at a couple final examples, put everything together, and then we'll call it a day. So we'll expand and simplify as much as we possibly can here. So first off, we're looking at root 6 all squared. So one of the rules we looked at in one of the earlier slides told us that right away this should be equal to 6. But if you're not sure, remind yourself this is just the same thing as square root of 6 times the square root of 6. Combine that underneath one square root, you get the square root of 36, which of course simplifies down to 6. In part B, this one can be a little bit tricky here because, inside each of these brackets here is not much to simplify. And we're trying to expand this out, and there's a lot going on with these radicals and this addition subtraction. So strangely enough, what I would actually suggest to do here is actually set this up using an array. Even though there's no x's or y's or any variables in there, an array might be the easiest way to actually multiply this out. So I'm going to draw out my array here and put all my terms in there along the outside. So I have 5 plus 2 root 7. And here I'm going to have 3 minus 4 root 6. And again, I'm just going to use my array, use multiplication to fill out all these boxes here, and it'll tell me what my final answer is going to be. So I'm going to do 5 times 3 to give me 15. 3 times 2 root 7. Well, 3 times 2 is 6, so you get 6 root 7. 5 times negative 4 root 6. 5 times negative 4 is negative 20, so I get negative 20 root 6. Okay, and here I have 2 times negative 4, so I get negative 8. And root 7 times root 6 is root 42. Okay, I'll check if that simplifies later. Let me just take all this now and make that my next line here. So all in all, this simplifies down to 15 plus 6 root 7 minus 20 root 6 minus 8 root 42. So we've gone through all the expanding. We just got to see if this simplifies any further here. So I'm going to see if these there's no like radicals here to simplify on. So that part can't be done just yet. However, I should check to make sure all these roots are in lowest terms. So 7's prime, they can't break that down any further. 6 has no perfect squares inside of it. And if we look at 42, well, if you think about it, we got 1, 4, 9. None of these go in there, right? So 1, 4, 9, 16, 25. Then we're getting too big. So this doesn't break down any further either. They're already in the lowest terms, so this is actually my final answer here. It doesn't look very pretty, didn't simplify any, but this would be my final answer. Okay, I'm going to take the exact same approach down here with C. In fact, I'd like you to try this one on your own first. Try the same idea, try and set this up with an array, expand it, simplify as much as you can, and see what you can get. So pause it for now and push play when you're ready to go through and see the answer. Alright, so you can take a look here. I set up my array, and just compare this to what you have on your sheet. So I multiplied, so I got negative 20, positive 12 root 5, 5 root 5, and then down here negative 3 root 25. Now I might see right away this is going to simplify, but all I did right now is I just wrote out all my terms here horizontally. So I have negative 20 plus 5 root 5 plus 12 root 5 minus 3 root 25. So I looked for any like terms that would simplify, so I've got 5 root 5 and 12 root 5, so I can add those together to give me 17 root 5, which I put down here. And root 25 you might have recognized right away as you were doing it that that's equal to 5. So you wind up with minus 3 times 5, so you combine that with a minus 20 and you get the final answer of minus 35 plus 17 root 5. Alright, so that's it, that's all. You got homework there for practice, and hopefully it goes well. Let me know if you have any questions. Okay, cheers.